Hi everyone, I am Dr. A. Prasanna, belonging to the Department of Chemistry, working as Assistant Professor in V.V. Vaniyaperumal College for Women, Virudhunagar. Now I am going to discuss the topic heterocyclic compounds classification. So before going into my topic, let me say a few words about what are heterocyclic compounds. Heterocyclic compounds are a stable ring structure in which one or more ring atoms are other than carbon, that is heteroatom. So we know the cyclic stable structure, that is benzene. In benzene all the carbon, all the atoms, ring atoms are carbon, but in heterocyclic compounds one of the carbon, that is one or more than two atoms, are replaced by heteroatoms like nitrogen, oxygen or sulfur. In sometimes silicon, phosphorus and some other elements are also maybe occasionally present. More commonly nitrogen, oxygen and sulfur containing heterocycles are present. Some examples are pyrrole, pyridine, furan, thiophene, pyridine, etc. We can quote many more examples for this heterocyclic compounds. I must point out why this heterocyclic compounds find significant role in chemistry. It finds significant role in biological system. They are the integral components of biomolecules such as DNA, RNA. Many vitamins, hormones and hemoglobin are of heterocyclic nature. In medicinal chemistry it finds significant role. Many medications are that is made of heterocyclic nucleus. Many medications which are used for cancer treatment, inflammation, infections, etc. they all have the heterocyclic nucleus. Also, heterocyclic compounds find significant role in agriculture. They are used as pesticides, fungicides, herbicides to enhance the crop protection and yield. Also, this heterocyclic compounds find significant role in industrial processes such as production of dyestuffs, sanitizers, antioxidants, corrosion inhibitors, and it can used for the synthesis of copolymers, also photographic sensitizers, etc. So it finds significant role in many fields in chemistry. Now let me focus the classification of heterocyclic compounds. Based on the size, since it's a cyclic compound, based on the size of the heterocyclic ring, it may be classified into 5 different classes. The first one is the 5-membered heterocyclic compound with the single heteroatom. The second one is the 6-membered heterocyclic compound with single heteroatom. Third one is the 5-membered heterocyclic containing 2 or more heteroatom. Fourth one is the 6-membered heterocyclic compound containing 2 or more heteroatom. The last one is the condensed heterocyclic. Let me point out the examples for all these classes one by one. First, let me say about 5-membered heterocyclic containing 1 heteroatom. That is, already I said the heteroatom may be nitrogen, oxygen or sulfur. It is present in the 5-membered ring system. So here the first example is the pyrrole. We may say that is pyrrole also. Pyrrole, that is the common name. The IUPAC name for that is azole. Azole. 5-membered, that is OLE. That should be ended with OLE, azole. Azo, it stands for the presence of nitrogen heteroatom in the ring system. So it's azole. Okay, so look at this ring structure. This is the 5-membered ring structure in which one of the atom is nitrogen. Then the second example belonging to this is furan. Furan, in which the heteroatom is oxygen. So this furan is the common name. The IUPAC name for this is oxole. Oxo refers to the presence of oxygen atom. Then thiophene, this is the next example for the 5-membered heterocyclic containing a single heteroatom. Here the heteroatom present is sulfur. This thiophene is the common name. The IUPAC name for this is thiol. Thio, it stands for the presence of, it denotes the presence of sulfur atom. So look at this furan and the tetrahydrofuran. This furan is the unsaturated form. So here this is saturated form of furan. So tetrahydrofuran, this is the common name. The IUPAC name is oxalane. Oxalane is the IUPAC name for it. Pyrrole is the saturated form. It contains 2 double bonds, whereas the saturated form, pyrrole is the unsaturated form. The saturated form of this is pyrrolidine. This is common name. The IUPAC name for this is azolidine. So these are all the examples for 5-membered heterocyclic compound with single heteroatom. Next, let me point out the second class of classification, that is 6-membered heterocyclic with 1 heteroatom. Here, look at this ring system. Here it is 6-membered ring system with 1 atom as nitrogen. Okay, so this is pyridine, or we can say this as pyridine. The IUPAC name for it is azine. The azine, INE, stands for the heteroatom with the nitrogen, that is azine. INE stands for the 6-membered cyclic system. Okay, so this is the unsaturated form. Its saturated form is said to be piperidine. So first case is the unsaturated form. The second example is the saturated form of pyridine. Okay, so some other examples are gamma pyran, gamma thiopyran, tetrahydropyran. These are all the 6-membered heterocyclic with single heteroatom. Coming to the third heterocyclic classification, that is 5-membered heterocyclic compound with the 2 or more heteroatom. So look at the first example. This is the 5-membered ring system in which the first and the second position takes up the heteroatom, that is nitrogen. In the 1-2 positions of the 5-membered ring system, nitrogen is present. So this may be called as pyrosol. This is a common name. Its IUPAC name is 1,2 diazole. Azole, it stands for 5-membered ring system with nitrogen. 1,2 stands for if that both positions nitrogen is present. Okay, so 1,2 diazole is the IUPAC name for this pyrosol. Coming to the second example, this is imidazole. Here the nitrogen is present at 1 and the first and the third position. So this is 1,3 diazole. This imidazole finds significant role. This is the basic heterocyclic nucleus in DNA RNA. Next, third example, that is 3 heteroatoms containing heterocyclic compound, that is 1, 2, 3 triazole. Here 1, 2, 3. In 3 positions nitrogen is present. Coming to the fourth example for the 5-membered heterocyclic with 2 or more heteroatom, oxazole. Here oxygen as well as nitrogen is present. 1, 3. In the first position oxygen is present. In the third position nitrogen is present. So 1, 3 oxazole. Ox, that represents the presence of oxygen heteroatom. Azo, that stands for nitrogen. So both the heteroatoms are present in this single nucleus. So oxazole, its name is oxazole. Then this is thiazole. The last example I have quoted here is thiazole. Thio, that is sulfur. Here the heteroatoms present are sulfur and nitrogen. in 1,3 with respect to one another. Okay, so 1,3 thiazole. So this is the third class of heterocyclic compounds. Then 6-member heterocyclic containing 2 or more heteroatom. Here comes first without the second nitrogen atom, it is pyridine. In pyridine, if you put nitrogen at the second position, that is 1,2 diacin, commonly it can be said as pyridacin. Acin stands for 6-membered ring system with the nitrogen heteroatom. So here pyridacin, 2 heteroatom, nitrogen heteroatoms are there. Okay. Second example, pyrimidine. Pyrimidine, it contains 2 heteroatoms, that is nitrogen at 1,3 positions. Okay. So this is 1,3 diacin. So this pyrimidine also finds significant role in DNA RNA structure. So this is the basic unit of DNA and RNA, pyrimidine. Then pyracin, it is 1,4 diacin, that is the 2 nitrogen atoms are at first and the 4th position with respect to one another. Then symmetrical triacin, this is also one of 6-membered heterocyclic with more than 1 heteroatom. Here 3 nitrogen atoms are present symmetrically, that is 1, 3, 5 triacin. Okay, yes, the last class of heterocyclic, that is condensed heterocyclic. It contains 2 or more fused ring system. So look at the first example. This is indole. So in this indole contains 2 ring system. One is carbocyclic, that is without heteroatom. The second one is the 5-membered ring system with nitrogen as heteroatom. So 2 ring system with the one is partly heterocyclic, another one is carbocyclic. Okay, so here this is benzofuran. This example, it also partly heterocyclic, that is carbocyclic nucleus is there, along with that heterocyclic nucleus is fused with it, benzofuran. So this one is also partly heterocyclic, partly condensed heterocyclic, that is quinoline. This one is carbocyclic, this one is pyridine. So the carbocyclic nucleus as well as the partly heterocyclic nucleus are joined together. So it forms a condensed heterocyclic. This isoquinoline, this is also partly heterocyclic. So apart from this, fully condensed heterocyclics are there, such as purines and pyrimidines. Pyrimidines already we have seen. Purine, that is the condensed system of imidazole and pyrimidine. Both these nucleus condensed to form purines. So these are the basic units of DNA and RNA. So this heterocyclic compounds find a significant role in many fields. So it's important topic in chemistry. Today I have dealt with the classification of heterocyclic. I will continue this in some other video. Thank you.